Today in geometry, we're going to look at section 10.1, properties of tangents. So we're going to look at the tangent line theorems. The very first one says, if a line is tangent to a circle, then it is perpendicular to the radius of the circle at its endpoints on the circle. Remember that perpendicular means creates a 90-degree angle. So here in this picture, we have circle P, and then we have this tangent line on the outside. So line SR, and it says line L is tangent to circle P at point T. Therefore, the measure of angle PTS, so this angle right here is 90 degrees, a right angle. And the measure of angle PTR is also 90 degrees. So we would have two right angles there. Our second theorem says if two tangent segments are drawn to a circle from an external point, then first, the two segments are congruent. Second, the angles between the segment and the line joining the external point to the center of the circle are congruent. So in this picture, we have circle O. We see that we have two tangent segments drawn from an external point. So my external point is A, so I have tangent line AB, tangent line AC. So those two segments are congruent. So I could say segment AB would be congruent to segment AC. And then the angles formed between those, okay, and to the center. So this first angle here, I could say that angle BAO is congruent to the angle on the bottom, angle CAO. So that's what those two parts of that theorem state. So let's now work on some problems. So number one, it says determine whether ER is a tangent to circle P at point E. Okay, in order for ER to be a tangent, then this would have to be a right angle. So to check that, we would do the Pythagorean theorem. Okay, so 17 would be my hypotenuse. So I would do the Pythagorean theorem and see, does it work out? Do I get a right triangle? So I would say 8 squared plus 15 squared. How is that related to 17 squared? Is it equal, greater than, or less than? So 8 squared is 64. 15 squared is 225. 17 squared is 289. So I'm going to add 64 and 225, and I get 289 and 289. So they are equal. Therefore, this is a right triangle, which means that's a right angle. So now we could say, yes, ER is tangent to circle P at point E. If I had gotten two different numbers on the left and the right hand side, then my answer would have been no, it is not a tangent line. So we're just checking Pythagorean theorem, seeing if we get the same thing on both sides. Number two, the figure shows the distance from the base of the lighthouse to a circular garden. What is the radius of the garden? Okay, so my radius, this is R here. Right? This is the length I'm looking for. My radius down here is also R. I'm going to use this top triangle though. See that I have a right triangle, and again, I'm just using Pythagorean theorem. So I have R squared plus 24 squared is equal to 25 squared. And I'm going to solve that, or I recognize that this is a triple. So remember when we learned about the Pythagorean theorem, we talked about Pythagorean triples. So one of the triples we talked about was 7, 24, 25. So my radius would have been 7. My units are feet. If I had not recognized it as a triple and I completed the Pythagorean theorem up there and solved for R, I still would have got 7. So now we're going to turn the paper over. Problem number 3, it says in the figure, SE is a radius and ET is the tangent to the circle at E. So therefore we know we have a right angle there at E. If SE is 12, so that's my radius, is 12, and E to T is 16, how far is T? Right. So how far is T from the center S? So it wants ST, so it wants X. Again, since I know that it's tangent and I have a right angle, it's simply Pythagorean theorem. So 12 squared plus 16 squared equals x squared. So I get 144 plus 256 equals x squared. So I get 400 equals x squared, but I don't want x squared, so I take the square root of both sides. So the square root of 400 is 20, so I get x is equal to 20. My units were in centimeters. So ST, the length of that is 20 centimeters. And so now below this, it says in the diagram, B is a point of tangency, so that means that this is a right angle. Okay. Find the radius R of circle C. So again, Pythagorean theorem. So this time I have R squared plus 80 squared equals, now my hypotenuse is this entire thing. This part is 50, this part is R. So the entire thing is R plus 50. Put that whole thing in parentheses and square it. So now on this side, I have R squared plus 6,400 equals, so R plus 50 quantity squared, that means R plus 50 times itself. So I can FOIL, or the shortcut method. The shortcut method says I take the very first term and I square it. So if I take R and I square it, I get R squared. Then the shortcut says I multiply the two terms together and I double it. So 50 times R is 50R. But if I double that, so 50R plus another 50R gets me plus 100R. And then the last thing I do is I take the second term and I square it. So 50 squared gets me 2,500. So now I notice I have an R squared on both sides. So if I subtract R squared here, notice how nice they cancel each other out. So now I'm just trying to get R by itself. So I'm going to subtract 2,500 from both sides. So now I have 3,900 equals 100R. I need to divide everything by 100. And I find that my radius is equal to 39. My units here were feet. So the radius is 39 feet. All right, directly across over here, it says RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of X. So this goes back to that second theorem that we talked about on the front, where I have two tangents. They both come from an external point. So that means that my two tangents are congruent to each other. So I would set this up and say 3x plus 4 is equal to 28. And now I'm just trying to solve for x. So subtract 4 from both sides. So I get 3x equals 24. Divide by 3, x is equal to 8. They didn't give me any units, so x is just 8. It's next problem. Find the value or values of x. Again, just like the previous problem we did, these are both marked as right angles, so I know that these are both tangents. They come from the same point, so they equal each other. So I say x squared equals 9. I don't want x squared, so I take the square root of both sides. So I get x equals, so here I put the square root into the problem. I have two answers, positive and negative. Square root of 9 is 3. So here I had two answers, positive 3 and negative 3. The next one directly across. In circle C, DA is tangent to A, and DB is tangent at B. Find x. So again, I have two tangents that are starting from the same external point. So that means that those two tangents are congruent. So I set them equal. So I say 6x minus 8 equals 25. And I'm just trying to solve for x. So add 8 to both sides. So I get 6x equals 33. Divide both sides by 6. So I get x equals 33 divided by 6. But I can reduce that because they both have a 3 in common. So x equals 11 divided by 2, or 11 halves. All right, our last example. Again, I see in the picture, okay, these are my tangents. So that means that they are congruent to each other. So I would set them equal. So I say 2x squared plus 3x minus 2 equals 3. I have an x squared and an x, so that means I want everything on the same side. So I'm going to subtract 3 over. So I get 2x squared plus 3x minus 5 equals 0. At this point, I can either factor or quadratic formula. So remember, the quadratic formula says x equals negative b plus or minus the square root b squared minus 4ac, everything divided by 2a. I'm going to factor this. Okay, so we're going to review from Algebra 1 days how to factor. Once you get to Algebra 2 next year, we expect that you know how to factor, so that's why we're doing more factoring right now. So remember, if I'm going to factor something, I take this number and I multiply it by that number. So 2 times negative 5 is negative 10. I'm looking for what two numbers can I multiply together to get negative 10, but add to get me the middle number, so add to get a 3. Well, what can I multiply together to get negative 10? 5 times 2 gets me 10. I need a positive 3, so that means a positive 5 and a negative 2. 5 times negative 2 is negative 10. 5 plus negative 2 is positive 3. So now we're going to factor this by grouping. So I need to rewrite the 3x using a 5x and a negative 2x. So I say 2x squared. I always put the smaller number first, so that's the negative 2. So minus 2x plus 5x minus 5 equals 0. So all I did was I took that 3x, that positive 3x, and I replaced it with negative 2x and plus 5x. Because negative 2x and a positive 5x is 3x if I combine them. So now factor by grouping. The first two I group together. The last two I group together. And so I say, okay, 2x squared minus 2x. What do they both have in common that I can factor out? They both have a 2 and they both have an x. If I take a 2x out, and remember factoring is just like dividing, so if I take a 2x out of 2x squared, I am left with x. If I take a 2x out of a 2x, or if I divide 2x by 2x, I'm left with a 1, because anything divided by itself was 1, but this was minus, so I have x minus 1 here. So now here I have a 5x minus 5. What do they both have in common? A 5. Parentheses, so 5x divided by 5 is x. Negative 5 divided by 5 minus 1 equals 0. The nice thing about factoring by grouping, I should end up with the exact same thing in both sets of parentheses. I did, so I know that I've done this correctly. I combine these two. So this first parentheses is going to say 2x plus 5. And then the second one says x minus 1 equals 0. So now I want to solve them. I set them both equal to 0. So I say 2x plus 5 equals 0 and x minus 1 equals 0. This x minus 1 equals 0, that's easy. I just have to add 1 to both sides. So I get x equals positive 1. So that's one of my answers. Over here, subtract 5. So I get 2x equals negative 5. Now divide by 2. So I get x equals negative 5 halves. So on this one, I had two answers. X equals negative 5 halves and x equals positive 1. Again, if you do not remember how to factor, or you don't want to attempt to factor, anytime you have an x squared, you can always use the quadratic formula and you would get the exact same two answers. All right, so that wraps up 10.1, all about tangents.